The immaturity of additive manufacturing as a manufacturing technology cannot be stressed enough. How do we advance all of the necessary technologies that support these new manufacturing technologies? How can we advance and weave those technologies together into workflows that actually solve real problems? Transportation and aviation are responsible for a huge fraction of the world's CO2 emissions. And while seat frames are relatively small pieces, there are hundreds of them per aircraft. Very small savings per seat frame can actually add up. One of the things that we sought to do was demonstrate some of the unique advantages of the casting process over conventional modern metal printing. In addition to shape optimization techniques, you can also optimize in the material space to a far greater degree than is possible with conventional metal printing techniques. Metal casting was actually capable of far more than we were asking of it. And we ended up demonstrating that actually something quite unique, quite compelling, quite valuable is possible. With optimizing both the geometry and the materials, we're able to reduce the overall weight of the seat frame by 56%. These weight savings really add up over time. It is so lightweight, it's unfamiliar. I've never touched anything like it. We have these really exciting tools, both in manufacturing and in design. We can simulate and iterate and optimize that can let us embed so much more intelligence and functionality and thought into matter. I'm really excited about what that means in terms of product design, in terms of the world that we live in. The amount of forethought and care put into the design things around us is going to grow exponentially over the next couple of decades. And that's a world I'd like to live in.